Hi everyone, I'm Cameron from ProHelion. This is my colleague.
I'm Sam.
And apologies for the noise. We actually have a solar car team building an electric vehicle behind us tonight. So if you hear a bit of banging and crashing back there, that's actually what's going on. We are building these videos to take people through some of the common challenges they have when building cars, particularly obviously when they're using some of our ProHelion products. And the thing we wanted to talk about tonight is inductor coils. And this is a particular favourite of ours because a number of people that we know that over the years have had issues with inductor coils. It's a really simple thing to solve. It can make your car a heap more reliable, particularly when you're putting it under load, like in qualifying. And so we just thought we'd take you through what the common issue is, why it happens, and what the pretty simple solution to it really is. So, Sam, do you want to take us through let's start with the problem. Let's begin there.
So typically in these high efficiency applications, the motors that are being used are ironless, and because of that, one of the characteristics is that they have super low inductance. And to work with the WaveSculptors, you need to have a little bit of inductance there just to slow the inrush of current during switching. Yeah.
Now, when you get that rapid inrush of current, what's the WaveSculptor going to do in that scenario? So
the WaveSculptor has built-in hardware overcurrent. So basically, as soon as it senses that the current threshold has been reached, it's going to throw an error and shut down.
And shut the transfer. And this is one of the most common things we see. People getting these hardware overcurrent. There is a variation of it called software overcurrent as well, which is similar. But basically what you're seeing when the WaveSculptor is doing that is it's effectively protecting itself from a scenario that would result in the WaveSculptor exploding. There's a lot of sensors in there that are basically looking for these signals early, and when it sees one of these situations emerging, it will shut down to protect itself from a situation that could lead to its failure. So what's the root cause of these overcurrent warnings going off in the WaveSculptor?
So there can be a couple of things. One can be just not having the inductors
in there at all,
in series with the motor at all. It's really easy to do, especially if you're new to electric drivetrains, and it's not something that you're used to doing. You just grab the motor and then you connect it straight into your motor controller. That seems logical.
And we've got to be honest here, we accidentally did this about half an hour ago ourselves as we were setting up for the video, so it happens to everyone occasionally.
To everyone.
Yeah, but fortunately we didn't switch the motor on, otherwise we would have got the hardware overcurrent. So we've got some inductors here on the table. Do you want to we've got two different sets, just to take you through what you're dealing with. What are these ones over here?
So these ones here are typically what are provided by some motor OEMs. They will allow the motors to run and run for most of their operating range. The issue with off-the-shelf inductors, in some cases, is that they're not capable of handling the phase currents that the WaveSculptor 30 is capable of switching.
Right.
So when you're getting to those higher current levels, the magnetic cores of the ferrite material in the cores of these inductors saturates. And they stop acting as inductors.
Stop working effectively. I mean, at that point, they might as well not have them there, right?
It just starts acting as coils of wire.
And unfortunately, this is going to happen usually when the motor's under relatively high load conditions, right? That's when we tend to see it as people get onto the straight or something with their electric vehicle, put their foot down, these will saturate, and then you start to see an issue coming out.
Right. Coming through corners, high torque moments in the drive cycles. That's when you're going to see those hardware overcurrents, which is exactly when you don't want that to happen.
So we've got some other inductors here. These ones are actually these particular ones are made by us, but you can make them yourself quite easily. The documentation for how you make these is up on our docs website, which is docs.prohelion.com. And what's the basic difference between these two inductors? Why? Take us through it.
So these are a little bit easier to manufacture. Which
these ones are? Or those ones are?
These ones are.
Those ones are, okay.
And because they're easier, they're that's why the OEMs will provide them. Using our instructions, these are also quite easy to make, but they use higher gauge Litz wire, so you have very low losses through them, and we also use a different core.
Right. Okay.
So that allows them to run at the the higher currents without saturating.
Yeah, okay.
And these are also potted in thermally conductive insulating epoxy as well.
Yeah, okay.
So it's able to, you can heat sink any of the heat coming out of them, which also helps to improve the efficiency of the cores as well.
Yeah, because I know when we've built these in the past, we've actually effectively bolted these to the side of the vehicle to dissipate heat and just keep it away from those critical systems. There are heat sensors typically in the motors, heat sensors in the motor controllers, so it is important to just be considerate of heat in these systems and try and make sure that you've got that. The common solution we've done has simply been to bolt them to the side of the vehicle and use the vehicle itself as a heat sink in the past. So that's great. So so recommendation would be if you're looking at building a system, you're using these motor controllers, if you've got inductor coils like these, sadly, some of these actually come with the motors that we commonly see used. So the motor manufacturers themselves, are providing them, but we still do tend to have issues with them. And the instructions that I've already said are on the website. You can build these relatively easily. The parts are available online. We've provided some very detailed instruction on what parts to use and some quite detailed instructions on how to build them. As always, if you've got any questions with this sort of stuff, reach out to us via support. There is a support system on the website where you can lodge support calls. If you've got questions, there's documentation on the doc site, and of course videos like this to try and help you get things set up and working properly.
Yeah.
So, fantastic.
No worries.
All right. Thanks for that.
Thanks, guys.
See you then.